Howdy. There's a bunch of things. You probably, maybe, remember this map I have drawn some time ago. It's the surface conductivity anomaly over Scandinavia, or in Scandinavia. How it is related to the Kursk magnetic anomaly, which is somewhere here. And how the spinning motion of these areas are sometimes even visible on radar. This is spinning this way, and this is spinning this way, so it creates this updraft, northwards draft. The worst scenario of all is a severe frost and windless high-pressure ridge that persists in the north, and Finland has not received an Olkiluoto 3 unit for commercial use, says Pia Örs, director of the Energy Supply Department of the National Security Agency. And it's sunny, it's rather cold, and here is another from Motion Magnetics, from a video. The actual spin vortex looks similar to this diagram. The north produces a counterclockwise spin, while the south a clockwise spin. So the thing is, here it says the north produces a counterclockwise spin, and I have been drawing here a clockwise spin. And here is a counterclockwise spin. So they are probably drawn in a way wrong. Or they have to be interpreted as how they attract the weather system. Plus attracts minus and such. So the weather system is spinning in this direction, even though that the magnetic field of this region spins into the opposite. And in a way, I think that this could probably make sense. And this map is related to weather, so this is how I found that. Because high pressure systems go like that, and low pressure systems go in the other way. So they are attracted by these opposite charged regions in the ground. This is windy at the moment, and here we have a low pressure system, and it is spinning this way around, counterclockwise. Since it is negative, it's a low pressure, 966 millibar. That's rather low. 1031 high pressure system here. Yeah, and you can see that it is also somehow spinning, even though not that obvious like the other one. That's almost not visible, but it's spinning this way. This is going this way. This is going this way. Next theme. Earthquakes. Unconfirmed in England, near Bristol 12 hours ago. Now let's just go very close in and check it out. Is there anything? 20 kilometers in depth, 20 user reports. No, it's 19, but it's rounded up. Water vanes. Aha. West Tanpit Wood. So there might be this kind of Markham Brook. This, how you call them? It's not a gorge. The small valley And the quake is some 80 meters away from that. It's rather interesting, and there is also this river here going into the sea, whatever river that is. River Avon. That looks rather interesting. What a beach. Yeah, there's a water vane. Aerosaurus. Yeah, check it out. Peatlands. And in a way, a white river, since the sea is blue and the river has a different color. But there were some other unconfirmed quakes as well. One in Poland, I think. This one. Yeah, unconfirmed. 18 hours ago. But I wanted to talk about these here. See that? 20 hours ago. 21 hours ago. 2.2. 2.2. 2.3. 2.4. 1.7. 1.1. 1, 0. 1.3. 1. 1.7. So they were all that happened some hours ago. Somehow I think there were more here. Yes. Yesterday. So I have been checking out a little bit Baltic Sea stuff, because I still think there might be stuff there which is overlooked or misunderstood or ignored or however, since no one else is talking about these. Hornfiskron, for example, that's the easiest one. Now obviously the sheep are gone. Last time there were sheep there, but that's somehow strange. Or maybe it was Google Earth, I don't know. That's the earthquake application. And there is also this island offshore of the Netherlands. Where are the Netherlands? Groningen. An earthquake hotspot recently emerged. And I think one of those, is it Borkum? No. Rotumerplaat, yes. Rotumerplaat is an island which has rather interesting features. It has a water vane drawn. Yeah, look at that. There is a facility on that. It's not marked or whatsoever. And this is a growing island. And it is very interesting. It loves you. Check it out. It has a heart on it. But there is a water source on this, I think, as well. Sweet water, fresh water, not salt water. But now about the quakes in the Baltics, I found something interesting. I found heat flow, seismic cutoff depth, and thermal modeling of the Fennos Scandian shield paper. Veikkolainen Kukkonen. Ilmo T. Kukkonen. Department of Physics, University. Yeah. Geophysics Journal International. And the year was 2017, I guess. Yes, here. Summary. Being far from plate boundaries but covered with seismograph networks, the Fenno-Scandian shield features an ideal test laboratory for studies of intraplate seismicity. For this purpose, this study applies 4,190 earthquake events from years 2000 to 2015, with magnitudes ranging from 0.1 to 5.2 in Finnish and Swedish national catalogues. 5.2. I just realized that's a rather big quake. Anyway, in addition, 223 heat flow determinations from both countries and their immediate vicinity were used to analyze the potential correlation of earthquake focal depths and the spatially interpolated heat flow field. Separate subset analyses were performed for 5 areas of notable seismic activity: the southern Gulf of Bothnia, east coast of Sweden; the northern Gulf of Bothnia, coast of Sweden; the Swedish Norrbotten and western Finnish Lapland area; the Kuusamo region in Finland; and the southernmost Sweden. In total, our subsets incorporated 3,619 quake events. No obvious relation of heat flow and focal depth exists, implying that variations of heat flow are primarily caused by shallow lying heat producing units instead of deeper sources. Let's read that sentence again. No obvious relation of heat flow and focal depth exists, implying that variations of heat flow are primarily caused by shallow lying heat producing units instead of deeper sources. Very interesting. Something shallower producing heat. This allows for construction of generic geotherms for the range of representative paleoclimatically corrected surface heat flow values. Geotherms constructed for a 3-layer. Yes, that's just reading. But let's just continue. The maximal focal depth of earthquakes has been frequently used to model thermal conditions of the lithosphere, especially to approximate the depth below which the ductile transformation dominates over brittle transformation of the crust. So this could be, in a way, clay layers. And by the way, now I just remembered the mystery of the Helsinki flooding is solved. The water pipes are just so old, they just break all at the same time. No mystery anymore to that, obviously. Let's see, is there something else too? But as far as we know now, the pipes are just broken because they are old. And since they were built approximately at the same time, it makes sense that they break at the same time. Anyway, there was something else which I found very interesting besides this one picture. Yeah, actually it comes when reading this. Like here I said about this clay, ductile transformation dominates brittle transformation in the crust. Maybe clay. And if it would be clay, it could be even mud volcanic in origin. And like I have many times said already, the geothermal activity, I think, has to be taken into account from both sides, the whole spectrum, from cold to warm, not only warm to hot. Might be very important. Because it would take all the waterways into account too. There would be all of a sudden a whole bunch of more things to look for. Really. But anyway, however, widely varying temperature estimates have been given for it, ranging from 260 plus minus 40 up to 450 plus minus 50 degrees, depending on the geothermal setting and the crust and lithologies of the area. However, the temperature of 350 degrees Celsius has been considered a viable choice for Fennoscandia, given the dominance of felsic rocks in its upper and middle crust, and the tendency of even small concentrations of liquid water to decrease the lithospheric strength. What happens to clay if you put water in it? It gets very soft. At temperatures close to the critical point of water, 374 degrees Ca2 MPa, whatever that means, the lithological composition of the crust is, however, not simple. Kuusisto et al. Modeled the crustal seismic velocity structures in the central part of the Fennoscandian shield using mixtures of different lithologies for the different velocity layers and concluded that quartz-bearing rock types are abundant from the surface down to a depth of about 25 to 30 kilometers. I got distracted because this name Kuusisto, it's a tree. It's the Christmas tree. It has this shape. Yeah, I'm not a drawer. That's a Christmas tree. You can put a star on top of it. Imagine this would be a star. And many people, they tend to light their trees up because out of pure easiness, if you have a string of lights and you start somewhere, you go around the tree and it creates a spiral on the tree. So, the Christmas tree is a Christmas tree because it represents plasma instability in the sky, Jacob's ladder. And this tree represents it the best from all the trees. That's why it's this particular tree as a Christmas tree. And with using a light band which rolls up the tree, which forms a spiral, it's even more interesting because of Birkeland currents and such. But anyway, I drifted up. But this was the distraction before when I was reading. So I got off this. Yeah, that was basically the thing about the water. Where was it again? Yes, we just scroll down. Here is actually something too also interesting. Weichselian glaciation about 9,000 years ago. Got to check this out once. Haven't heard about that, but it would fit approximately into the 12,000 year cycle, even though it would be like 3,000 years off, which would be a quarter harmonic. Maybe, I don't know. But we were talking about these quakes here in the Baltic Sea near Sweden, or in Sweden, which is one of those SO2 hotspots, by the way, as well. Let's go over to Windy quickly and take a look if there's any SO2 emerging from these regions and take a lines. There is here and here, Norway and Sweden. Look, see. And there is sometimes near Helsinki and of course also St. Petersburg and every now and then at Hornfiskrön. SO2 emissions, I have seen them. But anyway, the quakes, especially these here. No, why not these here? Not all the quakes. Let's zoom out a bit. So now here from the article there is this map. Heat flow. Paleoclimatically corrected heat flow map of Finland, Sweden and adjacent areas. Data from Appendix A. Check it out. There are some heat flow anomalies. Stockholm is somewhere here. It's not in the same vicinity. But there is something. And from this I created this little collage in order for you to see it easier in one picture. That's the island here. So the hotspot is somewhere here and the other hotspot is somewhere here. Goes actually a bit down. So is there anything going on beneath the Baltic Sea which could change quite many things? Just think about the impossible. Some mud volcano all of a sudden starts to erupt there. There has been gas bubbles already in the Baltic Sea. But anyway, I just wanted to show you these things because I thought they might be interesting. And they might be even important at some point of time. But we will see. Stay safe, stay aware, be prepared, inform yourself. Never stop learning. And I wanted to make still a shout out to one of my viewers who sent me a package with very cool things in it. I've never would have expected anyone would send me anything just because I make every now and then videos about things usually no one would care about. You know. So, a really big thanks to that. It was amazing. A book and some other very, useful things. And they are all related to this, what you see on the picture here. And it's amazing. Thank you very much. Thank you very much. It was very nice. Thanks. Bye.